This is my presentation on Chapter 7, Spacecraft Trajectories. So first off, what is trajectory? So trajectory refers to the flight path of a body. It could be, a plane, a spacecraft, just any body in motion going from one point to another. And some important components regarding trajectory are having clear and defined starting and ending points. You have to have a point A to a point B in order for there to be a trajectory. So some relevance and application. Right now, the big thing is reusable spacecrafts. This will lower the cost of spaceflight and allow it to be more accessible to space companies in general. Another one is satellites. So cell phones, internet, pretty much anything you do on your phone, all relies on satellites orbiting Earth right now, sending signals, bouncing signals around the Earth, and deep space exploration. So really, just deep space satellites, telescopes sometimes use this, but just mapping space flight for bodies that will explore deep space. So the big one right now is reusable spacecraft, and there's a race competition sponsored by the Ansari Corporation that offers $10 million to the first company that can successfully launch a manned spacecraft that can travel to space and return safely to Earth, and it can do this twice within 2 weeks. Now this is big because most rockets launch them off stage one rocket, stage two rockets. They all pop off and it'll get the astronauts to their destination. But it's tough to have the rocket come back in on reentry and land. And so the big thing right now is having a rocket that can launch a manned crew into space and then return in the same rocket and land safely on Earth, and have that rocket be able to be launched again within a certain time frame. Regarding deep space trajectories, um, as I said before, it refers to the flight paths through our solar system, and this is important because when scientists and mission planners are planning this, they have to take into account how much propellant they have in the rocket itself uh, to get from point A to point B to complete the journey. And so, to have enough propellant and to escape Earth's gravity, the mission planners have to choose a path that minimizes the use of propellant and in favor of gravity. So, a lot of times, the shortest trajectory is not always chosen. And a lot of times, satellites in deep space will wrap around, you know, other planets or other bodies in space and use the gravitational pull to give it that extra oomph needed so it doesn't have to waste fuel. And that's just it right now. And then in the future, as I said before, right now, many space companies are trying to launch a rocket, launch a manned spacecraft, and return it in a way such that the spacecraft is reusable and the crew is unharmed. That's a big thing. SpaceX, a lot of other companies are doing this. And then the big thing is mapping deep space trajectories and how it can provide satellites with new pathways to explore our galaxy and potentially make new discoveries, which is kind of cool.